Welcome back. You are given the root of a binary tree. The task is to find the maximum depth of the tree. And the depth of a tree is the number of nodes along the longest path from the root node down to the farthest leaf node. So yeah, here I guess it will be 3 because yeah, this should be 3. The approach, I guess we could use recursive function. And a recursive function is a function that will call itself over and over and over. And we have to find like some sort of base case. And the base case, it will the point where the recursive function stops calling itself. So if the tree is empty or root equals to null, the depth or the depth is 0, we stop the recursive. This is base cases. And in the recursive case, we recursively calculate the depth of the left subtree, which is max depth. We create like a recursive function. We call it max depth, and the right subtree will be like max depth as well. Root the right, and the depth of the current tree is the greatest of these two depths plus 1 for the current node. And yeah, this is how we do it. And we combine the results from the recursive calls and return the maximum depth. Okay, how we will do this one? Let me just start here in the coding. So it will be really easy one to solve. I will have like I would say if not root. If there is no root, we return 0. But how I did know that? It's a pretty important thing is to look all the time in the constraints before you solve any problem. So the node value could be less than 0 to 100, and also it could be null. Like it could be there is no node because the number of nodes could be from 0 to 10 in the power of 4. I guess I can see this one. Yeah, it's in the power of 4. So you have always to look at the constraints, because by then you will have a solid idea of what your base cases should be. We will do it in the left. So left, I'll call left depth will equals, I will call the max depth again, and I will put root.left, and I will like, let's call, no, I had to, const. And I guess we had to do the same thing on the right. So const, it will be right depth, and it will be root.right. And for each one, I need to return math.max. Okay, left depth or right depth, whatever is bigger than them. Whatever the bigger, and we add 1 for the current node. It's a pretty simple solution. It's like 4 lines of code. It's really simple one to understand, and I would say it's like an easy starting point for any recursive type of problems, because in the future when you start to solve dynamic programming problems with recursive functions, it will be way more complicated than that. And I know sometimes recursive function sounds that they don't have any sense because it's just a function that calls itself, and I guess this is not that easy to understand. But yeah, it was a pretty small problem. Let's submit the code and see if it will work or not. It did work. Okay, it would work beautifully. So yeah, that's it for this video, and see you in future videos.